Morning, everyone. Can you hear me?
Yes, can doctor.
Yeah. So I think all of you already go through the tutorial or the video online. Yeah. Hopefully you already start your tutorial or assignment I give you online. All of you download the assignment or not yet? So as I mentioned before, I wouldn't, this session won't be too long. I'll quickly go through some revision and then I'll show you some steps on how to solve some problems. Then you all can proceed for the quiz I post online. So basically on the segmentation I mentioned before, the pointer line segmentation is too primitive lah. Because in the real world, the real image actually you should have a better technique or better option to represent. If you look at any kind of images, they are more like a region, the group of the image, they are representing the region, yeah, object, yeah. So one of the way, the simple way of segmentation I will introduce today is like thresholding. I think you already go through the video. I wouldn't go through too much. I will focus on the step by step, how to solve. The first technique I will highlight today is thresholding. Yeah, any of you know what is thresholding? Yeah, you can tap, you can speak. Yeah, what is thresholding?
To put the minimum value.
You put the value is correct, not minimum. A threshold value, we call it threshold value. Yeah. Anything above the threshold we will set as one, no? Because like I mentioned before, if you want to segment the images, the easier way is we only want the shape, the final shape. Yeah, the object, like this one, the actual shape should be look like this. Yeah. So anything above or anything below, anything above we make it white, no? Anything below we make it black, no? Then you can see the whole object. Yeah. This is so-called thresholding. No? When you have the object, then easier for the next step, no? For classification, for store up the value, whatever things. So how to do the thresholding? If you look at the images again, I will quickly go through, I won't go through the whole lecturing process. If you look at the image, you can see, right? These images is a grayscale, like the different color tone. Yeah, yeah. For the image, normally we use as for this demonstration, we will just use a simple value like 1 to 8. Yeah, yeah. Not the wide range like 1 to 255. Yeah. So if you look at it, they have a certain range of value. If we put, let's say, this one into a histogram. I think all of you know what is histogram, right? Then you have this plot or distribution. If you look at the histogram, normally your images, you can see certain group, yeah, similarity lah. Like this one have two peak, right? Right. These two peak, what does this two peak mean? Can anyone give input? What is what kind of observation you can see for this first group and the second group? Yeah, what kind of observation if you distribute the images into a histogram? What you can observe? Yes, yeah, you can see two different group. No? One is toward, let's say here is which side should be white. Never mind. Let's say here is closer to dark. This one is closer to white. Then this group is more toward darker side, right? This group is more toward brighter color. Then you can set any value here. Yeah, it's not minimum value. It's a threshold value. Then if you set the value in between, then you can imagine if this one is a color code number or 1 to 8, let's say, then you set somewhere in between, let's say 4. Anything below 4, you instead of gray color, you turn it, become black. Anything above 4, you turn it into white. Then you have 2 different region. Then you can see the object. This is the very first one. So how, this is the basic concept. Then how to make computer understand this one? Anyone can give input. This one is a concept because all kind of algorithm or concept, yeah, no matter it's a new technique, like those who doing the master or PhD project, they try to reinvent or come up with a new idea how to do a new segmentation technique. So this kind of technique must be logical to computer. Yeah, logical means you must be something can be programmed, something that can be made into a logic sequence or program code step by step followed by computer. Computer is everything regarding 1010 or anything regarding logic. Yeah. So your formula, your coding, your algorithm should be something logic. So anyone can give input. If you look at this one, let's say the basic idea is thresholding is like that. So what kind of step you can involve? Can anyone give input? Just now you you distribute into a histogram, then you set threshold value, then the computer can make it into 2 regions. Then how to make this one into a step, logic step? Anyone can give input? How? Yeah, 2 different region. Yeah, reiterate all pixel value, set logic base. Okay, good guess. Okay, how to make this one into 2 different region? If we want to plot this one is too tedious, right? If you want to plot this one, plot this kind of threshold value is too tedious, right? The process, you need to map all the value into a distribution. Then you set the threshold. What's the best way to set this threshold? Any kind of formula, simple formula that you learned before in mathematics? What kind of value or simple formula lah? Simple formula, yeah. You learned before, right? Statistic. What kind of simple formula you can use to get this key value? You can give any idea, yeah. What kind of simple formula? The statistic you learned before, what kind of statistic you learned before? You learn what in statistic? You learn
Standard deviation.
standard deviation 2 at once, mean, right? Average, right? So if you total up the value, this one is quite similar to something like in between, right? Middle value, right? Or another one we call it maybe middle value. Maybe middle value is one of the best way to separate 2 region, right? Middle value. Yeah. How to get middle value? Average, right? You learned before, right? Mean, yeah. That's why first step, instead of you do the distribution like this one, too tedious, right? The process. You get the mean value. Yeah, you get the mean value for this one. Let's say you get this map, right? You have 1, 2, 3, 4, 5, 6, 7 times 749 value. Then you get the mean value as your first mean. Yeah. Actually, the best way is to get the mean. But another way is you just use a value somewhere in between. The global thresholding somewhere in between, like all the value bias towards 6, 7, some bias toward 1 and 0 and 3. Yeah. Then you set, let's say the first value, some value 5. Let's say 5. Then what happened? Anything above 5 will be in. You separate the image into group A and group B. A, anything above threshold. Right. B, anything below threshold. Yeah. Then you remap or regroup your image, or like this one. Can I draw something here? Like this one, you can see, right, very clearly here is one group. Right, the rest in, let's say this one is group A, this one group B, no? Then after you have two group, next step you iterate or repeat, no? Like just how someone say, because computer you can ask them to iterate, right? Right. Actually, the best guess for the first value you can use min, but for this, because it's manual based, your eyes still can see the value. You can set value, no? Set one initial value. You can use a min if you want to make it fully auto lah. You can use min value. Then after that, you calculate or anything belong to group 1, anything belong to group 2, you get the next average value, min, right? Then you get the in-between value. That means the two min you added up, divide by 2. Then you get the new threshold, right? The threshold value, we want the round number only, because this one is a round number, right? Then after that, you repeat using the new threshold, divide again into two groups, right? Repeat for 2 or 3 times, then the final value of T is your value. Okay, right? Any question on global thresholding? Yeah. I don't expect you learn it now because I already give you the video online in the e-learning. I expect you already do your revision. Today, more on focus on the real question. Maybe some is the question in past year exam or whatever things. Yeah, can be any kind of question. Yeah, yeah. Today more on to clarify anything you not understand. Then I'll give you the quiz question. Yeah. How we get 2.36 min ma? When you group up this one into one group, then you get the average value or the mean value. Ma? It's all added, right? 1 plus 2, 2 plus 3 plus 3 plus 1 plus 0 plus 2 plus 2 plus 1 plus 2. Divide by 9. Then you get this value. Yeah. Then same thing as this second group is the 6, 6, 6, 6, 6, 6, 7 until all the number, right? Not including this region, all the region outside. Yeah. You get 1.76. You check again. As long as the step is correct. Yeah, I not check this one. You need to check what's the actual value. Maybe it's 1.76. But this one, not worry, because any value thing you get here and here, you need to average it up. Then you get the new value. Then you reset again into two regions. Then until 2 or 3 times, you reiterate. After 2 or 3 times, you should get a stagnant number without any changes. Yeah, that means toward the end, maybe you get 4. You won't change. Next step, you still get 4. Then next step, you still get 4. Yeah, repeat 2 or 3 times will be okay. Because the example given to you is only a small range from 0 to 7. If the actual example 1 to 255, maybe you need more iteration. But for because in final exam or test or whatever thing, normally it's manual ways. We don't expect you write the coding. This one you can be programmed it, but we expect you use manual calculation. That's why we use a small number, small range of value, then you can iterate 2, 3 times as long as you get the concept. Yeah. Yes. Yeah. What happened to after you get this value? You get new, right? Right? Initial, new, then you repeat step 2 to 4. That means here the T will become 4, right? After 4, you divide into two groups. Anything above 4, one group. Anything below 4, one group. Then you compute again the new T. Yeah, that's why you need to repeat only for the whole process. You only need to repeat two times to 3 times. You should get a correct value lah. Yeah. Once you get the correct final value, then you do the thresholding using that value. Let's say the final value is 4. I need to stop this one, otherwise cannot. Yeah. Let's say you get final value is threshold is 4, then anything above 4 become 1. Anything below 4, 0. Now it's clear, right? The image is only a small piece, right? You can segment it out. Any question? Any other question? For thresholding?
Me, no, doctor.
Yes?
No.
Okay. Simple, right? But actually the global thresholding is mean what? Global means how to say? The whole image or global or what kind of disadvantages of this one you can observe from this global thresholding? Anyone can give input. What's the disadvantage? Advantage is simple and straightforward. Only 3 or 4 steps. Yeah. Yeah. Cannot have more than 2 region. No. Actually, the other way, that's why you can learn from, I think, I don't know, Joy will give you the example. No? They have another, they call it gray scale. Okay, gray levels thresholding or what. You can set 2 threshold value. Then you divide into 3 region. Yeah, like something like this. Three region. That one is more advanced. Yeah. But still, even though you divide into 3 region, they still have some problems. Yeah. But for our example, we only focus on 1 region. Yeah. Then the disadvantages of global thresholding is you cannot have more than 2 region. No? The other problem is if you observe like this image, if you use global thresholding, you might have because the real image, they will have this issue, illumination, right? When you snap photo, due to the light source or any kind of problems, your illumination, right? The camera, you take the image, then they have this kind of artifact. Your images will be uneven. Yeah. Sometimes they have some blur effect. Sometimes they have the maybe too dark or whatever things. Then you use a single threshold value, it will have a lot of problems. Yeah. Like for example, this one is single threshold value. You can't get the exact answer you want. Then the other way is we call it adaptive thresholding. Adaptive thresholding is instead of use a global single value, if you cut it into a small pieces, yeah, right? What happened? You can perform the global threshold value here. You assume this one is a new pieces of image, right? You process this one first, then you put it back. You process here, then you put it back. Then you process here, you put it back. You process here, you put it back. This one is called adaptive. Yeah. Any question on adaptive? Actually, the same process will go for each of the sub component. Yeah. But the main issue for adaptive thresholding, I think the example I give you don't have. You can find from online any extra example for adaptive. How to subdivide it, whether you want to go for 4 times 4 or 5 times 5, 6 times 6, or whatever thing. Yeah, normally it's an even number, lah, not odd number. Lah. 2, 4, yeah, kind of thing. Or how to determine whether you want to subdivide into 2 times 2 or 4 times 4. We can use variance value. Yeah, like just how someone mentioned before. Actually, all kind of algorithm, normally they use the simple statistic, mean, variance. Yeah. You can compute, for example, this image. You compute everything, then you get the variance. Let's say variance is equal to 1. Yeah. Then it equal to 1 mean what is mean by variance before I proceed? What you understand about variance? Variance. Yeah. Can anyone give input? What you understand about variance? Validity of sample. Can elaborate more? What you understand about variance? Let me go to the drawing board. In statistics, we learn is this one is mean, right? Your variance is this one, right? Right? Your variance. Yeah, really hard to draw here. Okay. No, right? What is mean by variance? This variance. Validity for mean cannot. That one is the too general, the concept. What happened to this variance? If this value is small, what I mean by small? If this value very big, what happened to this graph? If the variance is small, it means what? Very sharp, right? If the variance is large, what happened? The slope will be wider, right? Right? This variance value, right? Let's say this one variance is equal to 1. This one may be equal to 3. From this one, what kind of conclusion you can get from this variance? Yeah, distribution of data. Lah. Yeah, value less spread out. What happened to the value less spread out in terms of image? This one. That means what? The homogeneous, or what? Homogeneous or similarity, or the value of the image is quite similar. For example, variance equal to 1. What happened? If you apply the thing, now you see whiteboard or what? I want to close the whiteboard. Okay, now it's on the slide. Go back to the slide. So if we compute this one, variance equal to 1 means what? All kind of value here should be within tolerance of 1. That means all the values should be 6, 7, 6, 7, 6, 7, maybe 5, 6, 7, right? Then that means the whole piece of the image will be quite similar into one region. Yeah. If variance more than 1, what happened? What happened if variance more than 1? That means there's some dissimilarity, right? Right? There's some differences, right? Significant differences, right? Yeah. Same thing, if you take the height of your classmate, yeah, your classmate, your course, I think around your batch is around 80 or 900 people, I forget. Then you take the number of all the height, then you plot it. Yeah. Then if you get the very sharp, that means everyone same height lah. Then you cannot subdivide into smaller group, right? But if you get the variance is very big, that means the tolerance, right? Variance, another keyword is tolerance. Tolerance is very big, means what? A lot of error or a lot of different or dissimilarity. When you have dissimilarity is what? Means you have more than, in terms of image, what happens when you have dissimilarity? You have more than one region. Yeah, that's why normally you use the variance to determine whether you want to subdivide the images into smaller group or not. Yeah, this is how the adaptive thresholding perform. Yeah, the first step is the one whole image, right? Then you check the variance. If the variance is too big, then you can split maybe into two or into four, depends, yeah, on your algorithm. Yeah, right. Then you calculate the variance for this region again. It's still significant, right? Then you subdivide again. What I mean by subdivide, let's say we get the even number. Let's say there's x times x pixel, then you divide into 4 pixel times 4 pixel. Then you check again. This one variance still more than one, then you split again. Then this one same thing, you split until towards the end you get this one 4 times 4. Then you apply global thresholding here, put it back, global thresholding here, put it back. Then you get a better answer. That's what it mean by adaptive thresholding, no? Any other question? If no, then we'll proceed for the next one. Yeah. Next one is the optima, the one you learn by yourself now. Region growth, no? And region growth and region splitting. What is mean by region growth? Maybe before that, we go for your tutorial first. Tutorial don't have marks one. Tutorial the assignment. The ones is to give you some example. Quiz, yes, marks will be given. Okay, you try to solve this one. I expect you solve it before the class. Okay, solve this one. Give you 5 minutes. You can download from your e-learning. Yeah. I give you 5 minutes, then we'll come back and discuss. Yeah. I'll set the timer now. Solve this question before we proceed for the next example. You can start now, 5 minutes. You download from the online, actually I expect you download only from the e-learning, the assignment I give you. The one is considered tutorial, lah. Yeah. Yeah, this one. Download from here. Because I accidentally show the answer. Actually, should not show you the answer. Yeah. Yeah. Do that one. Ah, you only can see the slide. Okay. On e-learning, e-learning. Your e-learning, this one. Yeah, download from here. This one. Then you need to submit your assignment. This one, I want to ensure everyone do the online self-learning. Then this one to ensure everyone do the example. Yeah, stop the example. Otherwise, a lot of students after the class, they never try the example. Download it. I will extend for another 3 minutes. Try to solve it. This one is very simple and straightforward. I think you can solve it within 5 minutes. Yeah, download from here. I reset the timer. Give you another 3 minutes. Stop it. Then after class, you must submit it. This one no marks, just for attendance purpose. Because I don't want to burden you online putting for too long, maybe another less than 1 hour. Then emphasize more on example. Yeah, the example. Okay, download it, test it. 3 minutes from now. Second question. Start with second question first. Second question is global thresholding. Yeah. Then we'll go back to the question one. The region growth. Yeah. 3 minutes from now. Yeah. Download it. Second question first. Nice up. Okay, now anyone want to share your solution? I enable share screen already. Anyone done? You can share screen, show your solution, and elaborate how you solve it. Yeah. Anyone done? Anyone has solved it? Okay, 1 more minute. Anyone solve it? You can share screen. Anyone? Yeah. Never mind. I show you the step first. So actually, you need to compute mean. Wait. First step, you need to get the uh wait wait calculate the mean range. 31. Where's the question two? Okay. So you put the any number here now. Initially, let's say you have 4, 5, 6, 7, 8, 9. You put somewhere in between, or let's say put 7 as the first value, then or you want to initialize using the average value also can. Average means you use a mean value lah. Mean value you calculate it, you get let's say 6 point something, then you put 6. Then you set the p equal to 6. Anything below, anything above, you total up. Then this one is those pixel below. Yeah, you need to put lah. This one, let's say, uh, where is when? So this one, let's say your threshold is 6. This one is group A, right? A group A. Anything equal or below lah. We put equal or below is one group. Then this one group, first group, right? This one second group. Then first group, first group, first group, first group, second group, right? First, second group, first group, right? You need to do it that way lah. Yeah. Right? Then you total up all this number, divide by total, then you get the mean for first group, right? This one's first group below lah. First group. This one second group. This one first group. Sorry, second group. Second group. First group. First group. First group. First group. Second group. Second group. First group. First. 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 Right. Right. Then you compute how many? 1, 2, 3, 4, 5, 6, 7, 8, 9. Then you calculate. Then you divide, you get the mean for the first group. Then the other one, you total up 7 plus 9, blah, 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 blah. Then you divide, you get the second group mean, right? Wait, okay, I stop this one. Once you get the two value, then you use this formula. T equal to 2 mean value total up divided by 2, 6.29. Still get the 6, right? Right. When you set the initial and the second one is no changes, means actually you don't need to repeat. Yeah. You can run one time or two times because you set the first guessing value, let's say T equal to 6, then you compute divide into two groups, then you already get this one. No changes, right? No changes. Actually, you don't need to repeat. If got changes like 6, suddenly you get 7, then you try the 7, then you still get 7, then the final value is 7. Once you get the final value equal to 6, what happens? Then you repeat the whole images. Wait, and I mute or not? Okay. Then you repeat the whole images by using the threshold value 6. So if anything above 6 is equal to 1, anything below 6 is equal to 0. This one become what? 0, 0, 0, 0, 1, 0, 0, 0, 0, 0, 1, 1, 1, right? Then you get the final image. Any question on global thresholding? Any question? If no question, then we'll proceed to the next example. Okay, now understand, right? Yeah. Because I don't want to focus too much on the slide. I want to give you the example, the real hands-on. So easier for you. Okay, now we proceed for the next. The quiz question letter you need to submit by 6 o'clock. Because actually during MCO should not have assessment, but that's why I drag the quiz, give you longer, not the on the spot quiz. Give longer for you. Yeah. Like example here is the thresholding value. Which question? This question or question 1. Oh, now you know how to solve, right? Right. The one you need to do it. Wait, I share screen first. So this is the quiz and quiz. Which one? Quiz is this one. So the quiz question here, question 1, you go back and try submit it before 6 o'clock. Okay, then we proceed for the second part. Second example. Region growth. What is meant by region growth? Anyone can give input from this keyword lah. Region growing. What you understand from the keyword? Region growth. Anyone can give input? From this keyword, what you understand about region growth? Region growth, I think I don't give you the example because it's too simple. Yeah, but it happens in one of the past year exam, they come up region growth. So from this keyword, what you understand about region and growing? Can anyone give input? Hello, are you around? Too quiet. Yes, give any input. Region growth. Anyone can give input? Hello.
Randomly assigned.
Randomly assigned. What do you mean by randomly assigned?
Like go in random direction.
Okay. Any other question? Any other answer? The keyword grow here is mean what?
resources to make this bigger?
That means something will become larger and larger or bigger and bigger, right? Right?
Yes.
Yeah. That's why you come up from this keyword region growing. That means one of the region it will become bigger and bigger based on the concept of region. Because from the images that I mentioned before, it's not just a pure line or point or edge. Yeah, from the lesson one. It's more toward like a region. For example, if you look at the this picture, yeah, you can see they have the background and also the shape, right? Body shape, right? From your observation, you can see clearly here is a region background. Here is a region of the face, the t-shirt or whatever things, right? Right? What is mean by region? How you justify region in the logic way? Give some keyword. Yeah, region. If I say this image, who's Lawrence, the image here. The background is white, right? Here, right? It's a huge pieces of white, right? So how to define this one in computer? Because computer, everything must be logic. How to define these pieces of value? Is a what? Like I keep on emphasize the keyword similarity, homogeneity, and also the variance should be very low, right? Variance. How to define similarity? Like I mentioned before, right? Keep emphasize. If you look at the curve, right? If let's say the two, you compare two or three value together, how similar these three value? How to determine it by variance? If the variance is very small, means very similar, right? Right. If the variance is very small, means the two object is very similar, right? But for region growth, actually, it's not random. It's you pinpoint it or you define the seed point. We call it seed point. Yeah. That means you need to initiate the, like, for example, this image 0, 0, 1, 5, 6, 7 coordinate. This one is the coordinate 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Okay. How the region grow work? You need to pinpoint the seed point. We call it seed point. The first thing is, the first thing is seed point. Second thing is you grow the these two keywords. First thing you need to pinpoint, for example, this image, this one, 0, 0, 5, 6, 7, blah, 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 blah. So which seed point is the best one? You pinpoint, let's say my seed point is, I point here. Wait, let's say I pinpoint the seed point somewhere here. I start from here. Then what should you do? Next step is you do the region grow, means you check the surrounding value. You can go up, right? Go up is compared to the next one. 0 and 1 is very close or not? Let's say I put this one seed point as A. Anything similar to A, I will define it as A. Right? For example, here, the start point is here, right? Right? This one, right? Right? Then you compare with the next value. Next value, what happened? 0 and 1, is this similar? You check the variance. Variance. You set the simple one is you check, maybe not variance. You use the value. Anything differences, 1 equal to 1 or below is considered same region, right? Very similar. Then this one and this one, is this similar? Can tap in any answer? Is it similar? Anyone key in? This one similar or not? Is it similar? Anyone can give input? Oh, where's my chat? Similar, right? Then what you should do? If similar, it means this one is same group A, right? This one, then you check. This one now become one region, right? Right? Growing, right? From 1 pixel become 2 pixel. Now you check the neighboring one. This one similar or not? Similar, right? Same group, right? Then you check the surrounding. Here, before Langga Tiang, here's a boundary, nothing to do, right? Similar or not? Similar, right?
Similar.
Yeah, similar. These are similar or not? No, right?
No, only 0 and 1.
But if you want to use the variance, still okay lah. Then you check this one not similar, right? The final answer actually this one should not A. This one maybe B. If you use, depend on the value you set. If you set value differences, value of color pixel 1, then this one not similar lah. If you set color value within ranks of 2, yes, this one yes. Yeah, depend on the value you set. Yeah. For example, this example is absolute value less than 3 or okay lah. If less than 3, this one same group lah. Right? Then you get the answer. One group, then the other group. Right? But if you set less than 8, what happened? If you see initial value here, then everything will be covered up lah. Less than 8. Almost everything lah. That's why region growth, the key point here is the differences or the tolerance value you set lah. Yeah. Since this one is too simple, I wouldn't give you any example. You can have a look on this one. I will record the video, no worry. Yeah. Depend on the value you set and also depend on the set point you set. Yeah. Let's say I listed it, easier. I repeat the same example again. What is meant by set point? I repeat again. Because this one I didn't give you the example in tutorial or what. Let's say I set the initial set point somewhere here. Then I set the tolerance value within, let's say less than 3, something. Then you can start, you check this surrounding. This one same or not? Same, right? Similar, we do similar. Then you grow into 2 pixel, then 3 pixel. This one no, right? No, yeah. Similar. Then you go to that side. Similar. That side also. Similar. Then this one you can compare here, right? Neighbor. Now become one, this one is one piece, right? You check the neighboring. This one similar, right? Similar, right? Then this one neighboring also similar, right? Depend on where you start. Yeah. Any question on region growth? What's the disadvantages of region growth? This one is quite simple, right? The algorithm as compared to global thresholding. Global thresholding, what you should do? You need to total up the whole value, then find the mean value, split it, then compute the mean value of group 1, group 2. A lot of computation, right? But this one is what? Straightforward, right? This one you pinpoint any point, then you don't need to go through the whole image. You just check from the surrounding. Whenever you Langga Tiang or you have a very significant difference value, that means it's boundary. That you won't go through this boundary. Yeah. You won't segment out from here because the ranks you already set. Yeah. So it's straightforward, right? Very fast, right? You only just compare the neighboring value. Then you regroup it into one group. You need to keep record lah. This coordinate, all this coordinate is same group. Yeah. Then become one region. So what's this one is very fast, right? The algorithm work, but what kind of at least advantages? This algorithm is very good lah, but they have some disadvantages. What kind of disadvantages you observe? Can anyone give input before I go for the last one, last example, last topic? Disadvantages are not the tolerant value lah. You need to set sit point, right? Right. In the actual thing, your human eye can see lah. Or let's say I get example just now this image. If I want to segment the face, you need to pinpoint. Or here is the face key point. Then it will grow until the whole face come out, right? But in actual thing, this one will be semi-auto lah. That means still need the human effort, right? Sometimes we don't want the human intervention in the segmentation because every time the picture load, you need to pinpoint the sit point. Okay, I want to segment the background, okay, pinpoint here. Then from here, you grow, check all the surrounding, right? It's still not fully auto, right? So we don't want. If you want to have a very advanced system, we don't want the semi-auto. We want to have something fully auto. So how to make this whole thing fully auto then? I come with another algorithm, they call it region split and merge. It's still similar to region grow, but they use the same similar concept lah, but they split and merge. How they split and merge is similar to just now I explained the adaptive thresholding. Yeah. The whole images you check on the variance first. If the variance is greater than certain value, let's say we set 1. Then what happens? If the variance greater than 1, then you split into smaller region, right? This is a process. Then you check on this. Now you need to imagine now you have 4 pieces of image. Then you check on this one. The variance greater than 1 or not? By observing the number, you probably know now. But in actual one, you need to compute. Variance, you know how to calculate, right? Then this one, yes. Then you split again. This one, variance greater than 1 or not? Should not be now, because if you look at the number, you should know. But yeah, this one should be 1 or 0 here. So this one no splitting, right? Now here got or not? Let's say here is I think it's 0. If 0 means maybe yes. Yeah. If 1, no. Yeah. Let's say we're assuming this one is 1, the missing number. No, right? No splitting. Okay, we look at this region. Need to split or not? Yes, right? Right? This sub-region need to split or not? Don't need, right? This one? No, right? This one? Let's say all is 1. Yeah, don't need all. Okay, now we look at here. This one more than 1 or not? Yes. But you need to compute the actual one. I don't want to show you the whole process. You need to compute variance for any kind of pieces. This one is still splitting or not? If you need to, in actual test final exam, you need to compute the variance to show whether they need to split or not. Yeah, no, right? No, okay. This one, variance more than 1 or not? Yes or no? No, right? So your splitting it process until here. Any question? Split. If 2 by 2 is still bigger, then you split. Let's say here, the number here is very different. Let's say the number here is, you need to split until variance is less than the variance you set. For example, if you set variance is 1, then anything above 1, you need to keep on splitting. If this one, for example, this number is, let's say 1, you definitely get variance greater than 1, right? Let's say here is 6661, then you need to split until finally only left 1 pixel, you variance definitely less than 1. Then you split into this way. Any other question? 1 times 1, standard deviation equal to 0. Right? You cannot say no variance. No standard deviation is equal to 0. Yeah, less than 1. Yeah. right? The important key point for split and merge is this process. You need to check standard deviation, whether the split or not. If need to split, then you split it. Then when you split it, you check the smaller one, whether need to further split or not. Yeah, until you cannot split, then you stop. When you cannot split, then you stop. What happened? I need to clear, not clear, clear. Yeah, when split until you cannot split, then you, next step is you do the, what you mean by this one? Don't need, because standard, okay, I repeat the process. Okay, you draw, you check the whole piece, whole image. Variance definitely more than one, right? Then you split into half, a quarter. Then you check this one. If you look at the number, you know need to split. Oh, okay. Never mind, I repeat the process until 2 times 2. Because just now someone mentioned whether still need to further split or this one need or not? Need to split or not? No, right? Because the variance, the standard deviation is less than 1. This one need to split or not? Don't need. Okay, then this one nothing to do, right? Then you go to the second region. This one, let's say the number is 1, 1, 1, 1. Okay, split. You compute, you definitely get. This subsection 6, 7, 6, 6 need to further split or don't need, right? This one also don't need, right? This one, if all the number is 1, 1, 1, it's definitely no. This one, no, right? Then you go to this region. You compute, okay, this one need to further split again. This one needs to split or no, right? This one, no, right? This one, no, this one, no. This one, standard deviation is less than 1, right? Don't need to split. So your final split process is something like this, the image map, right? Then the keyword here, region, split, and last process, merge. Right? Any other question before I proceed? I continue on the last step.
Yeah, Doctor, what if we have, for example, the 6, 6, 6, 6? What if one is 2 or something? So how do we split? There's no variance anymore.
No more differences. Don't need to split lah. Yeah, you stop. You split until you cannot split, then you stop. Yeah.
Doctor, I mean, like if the square is 2, 6, 6, 6. So how do we split? There is no variance.
This one balance is equal to 0. You need to compute. I show you example without computation. Yeah, I need to show you all the computation will be longer process. Yeah.
In this square, can you put one of the values as 2?
No, example you can check from the slide. This one is how they compute. Wait, I stopped it. This one. If you look at the example, yeah, you see, this is the variance they compute. Yeah, right. Toward the end is this shape lah. Yeah. In actual process, you need to compute and write down the number. Like the first step, you divide into 4, right? You need to get the variance. Then if more than 1, then you split. Then you need to recompute the subsection here. Yeah. Yeah, right. Then you further split. Yeah. Until you less than 1, then you stop lah. Stop is similar, right? Like the thing I draw, right? Right. Then you put the mean value back. This is last process. Should I proceed to the last process? Yeah. Any other question? Yeah. Last process is you already have this mean, not mean, variance, not variance, standard deviation value. But you better you put the mean value back. This first square. This first square. What's the mean value for here? 6, right? Here is 6, right? You take the round number lah. 6, 7, 6. Maybe here is 2, 1. Here is 6, 6.5. We assume is 6, 7. Then you put the mean value back, right? Right, to represent the region. So this one, and now you need to do the last process is called merge. Is this similar to this one? Is these two similar? These two? These two similar or not? Yes, right? Then you merge. These two similar or not? Yes, merge. Right? This already one piece, right? This one similar or not? You put like maybe the value less than 1 or 2 lah. Similar, right? You merge. Then you check this one similar or not? Now merge, right? This one similar or no? This one similar or not? Yes, merge. This one similar or not? Yes, merge. Merge. Then merge and merge. Then what you get? Maybe I use another symbol easier. This one merge, you merge, then what's your final answer? This one, two region, right? Any other question? If no, then I show you the assignment example. Then further part, you need to do your quiz question before 6 o'clock. Wait, big drag already today. Actually, I target less than 1 hour because I don't want to burden you with the internet also. Okay, let me share the example. This one is they ask you to do the which one? Not this one. Yeah, you need to calculate fit and merge, yeah. Firstly, you compute the whole thing, then you get more than variance, more than one, then you split. Then after that, you compute again until you split. You get all this sub, right? Sub value. Then you finally, when you cannot further split, then you do the merging part. When you do the merging part, better you put the mean value here. Actually, this one should be the round number better. Mean value to represent all the small pieces, right? Some is big, some is small, right? Then you merge, right? Merge means the balance part I don't show you, you need to compute by yourself. Let's say we start from here. This one similar or not? Similar, right? Let's say we put less than 2. Or here example is show your output result less than 7. Okay. You can put less than 3 or 2 lah. Yeah. Then this one similar, right? Let's say less than 3. Similar, right? Right. Less or equal to 3 lah. Yeah. Right. Then you can merge. Merge this one. Yeah. Okay. Merge, 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 merge. Less than 3 all can. Yeah. Then this one will merge also. You compare with the surrounding. 6 and 5, 5 and 4. So your final answer will be something like this. Two region, but the computation you need to do it. Go back and do your computation. Yeah. Okay. Any last question? The tedious part will be how to compute and divide into smaller pieces. And then the final part will be merging. If you know that, I will end the session. Actually, the normally question will give you lah, not threshold lah. Actually, here is wait, here is using threshold or using what? Apply the split, completed. Okay. I need to show you the question first. Quiz. The quiz assignment. Actually, the value you should set lah. If they don't mention, you need to find one value. Lor. You need to predefine lah. Yeah. I'll check your answer according to your value. Find some significant value. For example, 3, 2, or 1. When you want to do the matching. Yeah. Any other question? If no, then I will end the session, or then you need to settle your assignment can submit by this week, but quiz submit by 6 o'clock. Yeah.
Doctor, I still don't know the answer to my question. If we have
Yes.
a square where there is we cannot split, but we need to split, what do we do?
Again?
If we have a square for 4 values where it's like 1 and 10 and 10 and 10. So how do we split?
Which one? Which one? Let's say we take this example lah. Okay lah. We take this example. First step, you compute the standard deviation. This one definitely more than. Let's say we set standard deviation. Let's say more than 2 or more than 1. Then you split no. Yeah, this one definitely you split it, right? But you need to do the computation. You cannot simply draw like I do. I take the shortcut. Okay, now you have 4 pieces, right? This first pieces definitely more than 1, right? We take maybe more than 2, more than 1, 2 small, right? Then you take this one. Still can further split or not? 3, 4, 5, 4. You need to compute. I don't know the actual answer. Maybe yes. If yes, then you split. Right? After done, then we proceed for this one. Can further split or not? Yes. Right? If the standard deviation. Right? But you need to show the computation. In actual final exam, you need to show why these pieces can be split. What's the value of the standard deviation? Then this one still, right? We go for this one, okay. Let's say we take one now, standard deviation, then you split again. After you're done, then you proceed for the second piece. Definitely this one can split, right? Right? Then you go for this one, can or not? Yes. Right? But you need to show the computation, not simply do like what I do. This one I take the shortcut by observing the number. This one, yes, right? Definitely the standard deviation will be more than 1. Right? Then you repeat for this one, yes, right? Maybe take more than 2 or 3. 1 is too small, right? The value. It takes that standard deviation more than 2. This one will be split or not? But you need to fix. You cannot simply change. Because if I take 1, all must be split. I want to show you example. It cannot be split. Yeah. Let's say standard deviation more than 2 or 3. This one cannot split, right? Right? Then you stop. This one can be split or yes, definitely. Right? This one can be split or not? If more than 2, still okay. The value can just is drastic. This one need to compute. I don't know. Maybe yes. What? Then you go for this one again. The whole piece, yes. Right? Then here definitely so much different. Right? Here also, right? Then here, maybe yes, maybe no. They say no, then don't think. This one, let's say no lah, then your answer will be something like this.
Okay, and how do we merge back?
Huh?
How do we merge back?
Compute a standard deviation. Standard deviation. Compute the standard deviation. You go back to the slide and then you repeat the process. You need to compute the standard deviation. I show you the shortcut. Shortcut means I don't compute. If you want to compute, you take longer time lah. I just show you the shortcut. Shortcut means I already assume you know how to compute. Yeah. The whole thing you compute the standard deviation, you know how to calculate standard deviation, right?
Yeah, but doctor, to calculate the standard, we can calculate the standard deviation for 4 values, but how do we calculate the standard deviation for only one value?
Again?
We can calculate the standard deviation for 4 values, but how do we calculate the standard deviation for only one value? Because after we split even more, it's only one value. So how do we calculate the standard deviation
Then
for one?
you need to split first. After you split, you draw back the picture, then you compute again. For example, you split it already, right? You already split. Right, you compute, let's say the first one, I don't know, standard deviation maybe more than 2. You split already, right? Then what you should do, now your image become 4, right? Then you need to compute the standard deviation for this one. The whole thing. Right?
What I mean, doctor, is after we further split until it's only one value in the square.
Not only one value, split until you cannot further split according to rules. Like rules, if you set standard deviation equal to 1, that means you need to compute this one standard deviation more than 1 or yes, then you split lah. But you need to show the answer lah, like this one, the process, the step. Like I don't show you the full thing because I assume you will study the slide. I won't go through the whole detail. I already record the video. I assume actually supposedly I should not show you the whole process. I just give you the assignment. Then if you have any question to ask, then we can discuss. I don't expect to give you full lecturing online because I already do the recording, do some quiz, not some question online, post online for you to answer. I assume you will have self-study. Yeah. I don't expect you will come here and ask me A to Z. Yeah. I will just highlight on what kind of thing not clear, like just now the global thresholding. Yeah, I will just repeat the example again. Then if you don't understand, I will explain. So I expect you already go through the slide, understand what I mean by subdivide. Then I can further elaborate. Yeah, easier lah. Otherwise, if you assume here, then I will explain A to Z. No point I do the recording online, all these things. Yeah. Then you will be very burdened. Everyone come here for 2 hours, 3 hours. Then the data you use, everything. So actually, I repeat finally. Okay, you compute subdivide, then you need to compute standard deviation for this one, this one, this one, and this one. Then you'll get this one, the four subdivided thing. Then you check off this one 2.1, right? You need to further divide this one also, yes. This one, yes. This one, no. That's why from here, this one don't need to subdivide. This one, yes. If yes, then you need to go for next step. You need to, or you these 3 sub thing you need to subdivide, right? After subdivide, then you compute the standard deviation here. This one, this one, this one, this one, right? right? All this one becomes a smaller subdivided thing. But this one don't need because if you check the standard deviation already, yeah, less than the one, right? Any other question? Then you further next step, you check again all these small pieces standard deviation. You need to do computation something like this, right? Right? The square, small square. This one less than one, less than one, less than one. Don't need less than one, less than one. Less than one, less than one, less than one. Don't need less than one, less than one, less than one. Okay. Then you get the region, the mean value, put in back. Then you remerge it. Yeah. This is the whole split and merge. Any other question? You go back and try lah. You must try the example. That's why I give you assignment and quiz. Otherwise, a lot of students they'll just pretend nothing, listen. Then toward the end, they learn nothing. Then during final exam, they don't know how to do. That's what happened. Yeah. I think that's all for today. Now I will post for maybe 1 minute to show to let anyone know it slide in. Yeah. Those not yet slide in, I will leave the room on for another 1 minute. Okay. Kindly slide in anyone.
Can you see my camera?
Yes. Wait.
Okay.
Okay. Yes.
Okay. So what I mean is this one is just 1, and this is 6, 10, and this is 15. Okay. So we already calculate the standard deviation here, and it's more than 1.
Then split lah.
Okay, we split. How do we calculate the standard deviation only for this?
If only one number, that means the standard deviation is equal to 0.
So standard deviation 0. Okay. Okay.
Right. Only 1 pixel. You have any differences or not? The differences will become
0.
Yeah. No differences. Yeah, that's it. They will. You cannot split 1 pixel into, I don't know, 0.1 pixel, right? 1 pixel. The last one will be 1 pixel. Yeah. Any last question? If not, then we'll end. No? Anyone not yet slide in or not? If yes, then I will turn the switch to the slide in page. Anyone else not yet slide in? Yeah. Okay lah. I think that's all for today. Make sure you submit your quiz by 6 o'clock. The answer. I extend it longer because I know it's F0. That's why I don't set the limit. Actually, supposedly the quiz will be submitted by 1 o'clock or 2 o'clock. I extend it. Yeah. Okay, thank you everyone. This session I will record it. Maybe later I will upload online. Not today. Need to convert everything. Yeah. Okay, everyone. Okay, bye.